Oh. Okay, so this chapter we are going to learn two things: radioactive decay, or we call it as radiation. When I say radiation, I'm saying alpha, beta, or gamma. Then we are going to learn what is half-life. Then what is nuclear energy with E equals to mc squared. And what is fusion, nuclear fusion, nuclear fission. And then this chapter is related to a drama called Chernobyl. Chernobyl. If you have Netflix, you can go watch. Okay, and we also will learn what is we use nuclear reactor, we use nuclear power plant, so we will use the nuclear physics. And why the tragedy happened, you can watch from the drama. All right, so now what is radioactive decay? It's a must to remember as definition. It's a process in which unstable nucleus become more stable nucleus. Or if you read some books, they will say unstable nucleus is parent nucleus, more stable nucleus as daughter nucleus. Unstable parent nucleus to more stable daughter nucleus. So how to make unstable nucleus become more stable nucleus? We need to admit out something. The things that emit out, we call it as radiation. And what is radiation? Radiation 1, alpha, alpha. Radiation 2, emit out radiation 2, beta. Radiation 3, gamma. Okay. So emit out radiation means either alpha, alpha, beta, or gamma. So now can you remember the definition already? 1 minute and I will call your name. Okay, now may I know what is radioactive decay? 来文琪可以回答吗？不要看可以回答吗？文琪可以回答吗？
文琪在吗？
你可以开麦吗？麦，开麦。什么是 radioactive decay? It is
radioactive decay. It is a process that make unstable nucleus become a more stable by emitting radioactive radiation.
Yeah, thank you. Wenxian, can you please tell me 3 radiation? What are them? Maybe one Cheng. Maybe
Gamma.
So radiation maybe alpha, beta, or gamma. Okay, so I consider all of you already have that. So later at the end of the lesson, I will still ask back this. Okay, so now actually what is alpha, beta, and gamma? I cannot open. Teacher, no sound off. Thank you. And yeah. Yes. Teacher, again. Okay, so we look at this periodic table. I believe all of you quite familiar with the first two rows already. We just look at the first two rows. Just now you can see the carbon is number 12. Then the nitrogen is number 13. Okay. I can't. Okay, let's go. Okay, so now what makes a carbon is the proton number 1, 2. So you can see when it's vibrating, it's not stable. 3, 4, 5, 6. 12 means 6 proton plus 6 neutron. Okay, see how to make it stable. 1 neutron, 2, 3, 4, 5, 6. See, stable already. We don't count the electron yet because radioactive decay actually is the problem of nucleus not stable. See, this is carbon 12. See, 6 plus 6, 12. Mass number is 12. So we put 13, 14, unstable again. Okay, so how to make it stable? We need to take out some neutron, or we mix the neutron breakdown. Okay, how is it? Look at this video.
It is only in the last one.
Okay, this is atom. So I believe all of you learned in chemistry already. Atom inside got proton and neutron as nucleus. So this is electron always orbiting outside. So we don't see them first.
100 or so years that humankind has understood that the nucleus of the chemical elements is not always.
So this is carbon 12. Carbon 12 means 6 protons, 6 neutrons.
Fixed. It can change spontaneously from one element to another.
And it will become a nitrogen when it becomes stable. How is it?
The name for this process is radioactivity. You probably already know something about the nucleus. It's much tinier than the atom.
So you know that atom actually is nucleus at the center.
It's made of particles called protons and neutrons.
Okay, protons and neutrons.
There are electrons orbiting around it. And though the atoms can share or swap electrons when
So this is the force of attraction, H2.
they bond together, the nuclei themselves never change. Right? Well, no. Certain nuclei are not stable in that way.
See, beryllium, boron, carbon, neutron.
This means that
The second row, see, lithium, beryllium, boron, carbon, neutron.
they may change suddenly, spontaneously.
Why when they when they sneeze, it becomes neutron?
The radioactive nucleus flings out a small particle and transforms into another element, just like that. For example, a carbon nucleus can eject a fast-moving electron and turn into a nitrogen nucleus. There are two different particles that can be emitted from radioactive nuclei, though never together. The very fast electron is known as a beta particle. If you know a little bit about electrons, you may be thinking, what was the electron doing in the nucleus in the first place? The answer is that a neutron in the nucleus spontaneously changed into a proton, which stayed behind.
Okay, so actually, just now this one is a neutron. Then because unstable, they want to make it stable. So this neutron will transform into a proton and an electron. Okay, so now this become a proton and electron. So neutron split become proton and electron. So now what's happening here? Here is a proton 6, neutron 6. But now that one neutron minus 1 become 5. Now neutron become 5. Then it changed to proton already plus 1, so it becomes 7. Then change to one more electron emitting out, go out. So now, what is P7 neutron 5? Let's look back here. Okay, now P7, 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 3, 4, 5. Okay,
interesting, right? Jigsa's thing looks a lot more interesting.
Sorry? Sorry? Damien, sorry?
Sorry about that. It's just managing another client, another meal, so sorry.
Okay, whatever. Okay, if you have any questions, you can always stop me, or you can always ask me. If any part that not so clear, just raise your hand and ask it. All right, so now this is, even though it's still unstable, but when it emits out the carbon neutron become a proton and electron. So now it become a nitrogen. Still unstable, so it will continue do the radioactive radiation. Okay, so just now the carbon emits out an electron and gain one more proton. Okay, so this process that emits out radiation means either alpha, beta, or gamma. The electron that emits out, we call it as beta. Okay, beta. the electron that emits out, we call it as beta. So this is called radioactive radiation. So from unstable to more stable. That's why just now the book say unstable to more stable, because still not stable yet, but better than just now already. Now see. Okay, so now continue with C.
And an electron flew out as a beta particle. This is not what chemistry has taught us to expect. The nucleus is supposed to be stable. Neutrons don't change into protons, except sometimes they do. The other part
Okay, so neutron change to proton and electron because they want to be more stable.
particle that emits spontaneously from an unstable nucleus is alpha.
Actually, yeah, for example, there is this thing.
Particle that emits spontaneously from an unstable nucleus is alpha. An alpha particle is 8,000 times more massive than beta, and it's a bit slower. Alpha is made from...
Okay, what is an alpha? Same thing. Just now when electron is emitted out. Emitted out means they throw out. You can admit out means throw out. But don't use the word throw, we use the word admit. Okay, because scientific word, we must use scientific word lah. Okay. Then this is alpha. Alpha. The symbol is like a fish. Okay, what is alpha is they want to make stable, so they emit out 2 proton and 2 neutron. Nucleus only. So actually, what is 2 proton plus 2 neutron? We check back here. 2 proton, 1, 2, and 2 neutron, 1, 2. Oh, it's helium nucleus. So actually, what is alpha? Alpha is when we say alpha, we say it is a helium nucleus. But when we say beta, it is a high-speed electron. And I think you may find out, this thing same as cathode ray. Yeah, almost the same, but cathode ray has lower speed lah. Then some more, cathode ray is a beam of ray, a beam of electron. This is 1 electron only. Okay, so now when I ask you what is alpha, you must be able to answer me. It is a helium nucleus. When I ask you what is a beta, you may tell me it is a high-speed electron. Then what is a gamma? Let's see.
2 protons and 2 neutrons. If we trap a lot of alpha particles together, we get helium gas. Alpha is a helium nucleus.
Okay, alpha
We get helium gas. Alpha
is a helium nucleus.
is a helium nucleus. Like the beta particle, we would not have expected a heavier nucleus to throw out helium. But again, it happens, and the nucleus becomes a new element. So, is radioactivity useful or just dangerous? Wherever you are sitting, it is quite likely that there is a device near.
Okay, this is a smoke detector. In Malaysia, we seldom use this. Because we always open our windows for our masakan. But for other country, you know lah, the European people, their country is very cold. So they like indoor cooking and normally no smoke. So if too much smoke, then it will be fire. So this is a smoke detector. How they use the radioactive things.
Nearby, which contains a source of alpha particles. A smoke detector. The source is radioactive
Americium.
You are totally safe from these alpha particles, which cannot travel more than a few centimeters in air.
Okay, for these alpha particles, because it's big size, so it only can travel a few centimeters.
Beta particles penetrate much further through materials.
Okay, so alpha particles is helium nucleus is quite big.
Beta
So a paper can stop it. So alpha particles is big, is huge. So a paper can stop it. And let's see.
particles penetrate much further through materials than alpha can. Radioactive.
Okay, but beta particles is much smaller, so it can pass through a paper. Pass through a paper, we use the word penetrate through. We use the word penetrate. Okay. Okay. Then continue.
Atoms are used in medicine as tracers to show where chemicals travel in the patient. Beta particles.
Okay, so now okay, iodine solution. Iodine. Iodine can be can have radioactive decay too. Okay, and we also can use the sodium. Sodium also got the isotope. Also, some are not stable. When we inject inside the vein, it will flows back to the heart, and then it will pass through the whole body so that we can check which vein is blocked. So since we know it will have radiation. So if this part have too much radiation from a detector, we can check, okay, this part is blocked. So see how sometimes you can use medicines to clear the blockage, or sometimes we need a surgery, right? So only beta can penetrate through our body, alpha cannot.
Particles are emitted and have enough energy to emerge from the body and be detected. There is a third type of nuclear radiation, gamma, which is not a particle at all. It is an electromagnetic wave, like microwaves or light. But
okay, so actually gamma has no particles, so it's an EM wave, electromagnetic waves. Last year we have learned the waves like this. Okay, so lambda increases, frequency decreases. Lambda decreases, frequency increases. So this is the spectrum of EM wave. Spectrum of EM wave. So here started with radio waves and ends up with gamma ray. So actually gamma is a ray. Is a wavelength. So now I want to test. Do you still remember in between them? Like after radio wave is what? Like Xinheng. After radio wave is what? Xinheng. Okay. This way, from this machine. Xinheng, 在吗？Xinheng. Okay, 开麦吗？不记得了。好。How you just came in. Last year, this is last year knowledge. 来英知 what is next after the radio wave? Put it out.
Sphere.
Actually, it's microwave. After that would be infrared. After that would be visible light. What is the color? Must. It's a must to memorize. If not, you cannot answer question 1. So then would be ultraviolet. Then would be X-ray. Then would be gamma ray. Spectrum 红橙黄绿蓝靛紫 English Roy give birth. Roy give birth. Okay, so actually just want to tell actually a gamma is a wave. Is a wave lah, then no particles.
It is actually 1,000 times more energetic than visible light. Gamma rays may pass right through your body. Gamma is used to zap the bacteria
Okay, so gamma ray can pass through our body, can kill our cell, and also can kill the germs.
in fruit to increase its shelf life.
Or it can kill our normal cell, but if we concentrate it on the cancer cell, it can kill the cancers.
Or in radiotherapy to kill cancer cells. Radioactive substances get hot, and this heat can be used to generate power. This heat
Okay, can see we can use one radiation.
get hot.
We can make one radiation to spread
And this
to
heat can be
spread to others' nucleus. So the radiation can continuously happen, and the heat that generated we can use to turn the turbine in generate.
used to generate power. This heat has been put to use in space probes and, in the past, in pacemakers for hearts. The more abruptly nuclear radiation
Okay, this is a radioactive substance. If we want to make it continuously have radiation, we can use a neutron to hit on the atom. Then you can see 2 electrons is emitted out.
is slowed down, the more damage it does to the atoms it hits.
Okay, so ionization, I believe all of you learned in chemistry already. Or anyone, do you need I explain what is ionization? Okay, now ionization means an atom is neutral. Positive, negative is okay. Then when you make it, when something hit it, it will become positive charge and electron out. So it will become ion. It will become positive charge and negatively charged. So neutral atom become ion. This is called ionization.
This is called ionization.
Okay, so
Alpha causes the most ionization as it crashes into other atoms, and gamma the least.
okay, so actually here,
Nuclear
see.
radiation.
Okay, so this is an electron. Radiation electron, we call it as what? Like Darren can tell. Radiation electron, we call it as alpha, beta, or gamma. Darren can on my fast. Darren 在吗？ Darren
哪一个 Darren 老师？
这个 electron 哪一个 Darren 有2个 Darren Darren 不是一个吧没 Darren Wong 吗了不是有2个没好啦就 Darren Wong 啦OK Darren 回答了 OK yeah Darren this is a beta if we want to say it's beta also can Darren Wong 5A Darren Chin 5A OK 好谢谢Okay, so now you can see from animation, When beta hits a radioactive substance, 2 electrons drop out. Darren is made up of Darren. Okay, Jinwei, 谢谢. Okay, now C.
Is slowed down, the more damage it does to the atoms it hits. This is called ionization. Alpha causes
Okay, can you see?
the most ionization.
This is alpha. When alpha hit a chamber, bury the light. Can. So when alpha hits on the unstable atom, it will drop out 3 electrons. Okay, then let's see.
As it crashes into other atoms, and gamma the least.
Okay, when gamma, they say gamma, but I like to say gamma. When gamma ray hits on it, only 1 electron is dropped. So we can get a conclusion. 1 electron is dropped means the ionization power. So ionization power is depends on the, we say high ionization power when more electron is hit and drop. So we say alpha has the highest ionization power. Okay, then because alpha is the biggest particles among the radiation, beta is an electron only, so ionization power moderate. Gamma is an energy, no particles at all, so the ionization power would be the least ionization power. Okay, so on the other hand, we also can say gamma penetrate through something will cause least damage. Okay, gamma is more dangerous than alpha because it can penetrate. But if penetrate through, it will have least damage. Okay, so now we continue.
For humans, the most serious effect of radiation is the damage that it can cause.
Okay, so this is the DNA. The DNA. So if alpha, beta, gamma hit the DNA, it will be broken, means it will be cancer.
To our DNA. Although alpha cannot penetrate your
Alpha cannot penetrate through our skin because a paper can stop it already.
skin, if you inhale or ingest a radioactive nucleus, the health consequences can be severe. Radioactivity is both useful and deadly.
Okay, radioactivity is useful, but it's dangerous too. So we need to know the characteristics so that we can use it in proper way. All right, now let's look at our module. Okay, before we continue, I want to ask, tell me what is radioactive decay? Like Darren Chin. Radioactive decay is and on my fast. Darren. Okay, never mind. Okay, why I always stop and ask you to recall? Because if you don't recall, it's hard to last in your memory. Okay, like Hui Ting, Isabel Lee. Isabel, what is a radioactive decay? I'm helping you to make it last in your memory. I just tell here. What is radioactive decay? Isabel?
Can I say just losing radiation over time?
Losing radiation over time. Cannot. When we say definition, must be the international definition. The format is like this. It's a something which or where or blah blah blah. So you must tell what is it first, then you tell how is it. For example, who is Chaser? You must tell Chaser is a she. She is a teacher. Who? Describe who teaches physics. See, your format must have which, who. And we tell definition. Anyone can try? Fast.
Radioactive decay is an unstable atomic nucleus that loses energy through radiation.
No keywords. Because I mark SPM paper. I mark paper. They want the keywords from what kind of nucleus to what kind of nucleus. Này. You just now you have unstable nucleus, but you didn't say become what kind of nucleus.
Stable nucleus?
Sorry?
Is the answer stable? It becomes a stable
More
nucleus.
stable.
More stable. Okay.
Still not so stable, but become more stable. Yeah, very good. Yay, correct. Yeah. So if you didn't tell by emitting radioactive radiation, actually it doesn't matter, but you must tell until unstable to more stable nucleus. Nucleus is nucleus only nucleus All right, so next, radioactive radiation. I want to ask, the high-speed radiating wave was beta or gamma? Yeah, this is what I want to ask. Radiation got 3. Number 1, number 2, number 3. Okay, for example, I Wen Sheng just now. Tell me one, Wen Sheng.
Alpha.
Okay, alpha. Looks like this. Actually, what is an alpha? It is a yes, Yasha. Wen Sheng, it is a
Helium.
helium apa? Helium without electron called what? Nucleus. Thank you. So how we write helium with in chemistry way? He42. Okay, so this is atomic number, this is proton number, means inside got 2 proton and 2 neutron, 4, 2, right? Now, may I know what is the radiation for number 2? Any volunteer?
Beta.
Sigma.
Looks like this. What is a beta?
Electron.
Yay, high-speed electron. So how do we write? We write as electron. Electron means no proton, no neutron, so 0 on top. No proton because it's -1 is electron. So we write like this. Okay. Let's see. Then the last, Joshua. The last is yay, gamma, correct. Excuse me. Gamma. Okay, how we write gamma? Nothing, it's a wave. So we say gamma is a wave. Okay, we just write gamma because no particles, no nucleus, no electron, it's just a particles. All right, so now, this one you all copy lah from your answer. Okay, so alpha decay. Alpha decay is one of the radiation. So alpha is like this one. He42. So example, the format is like this. The nuclear equation. We must know the nuclear equation too. How do we know it's helium? Normally exam would be like this. They say, this uranium become a thorium. So this is X. Then they ask you, what is X? Okay. What is X? Or maybe we call it as a P. What is a P? What is a radiation? We put X on top, we put Y at the bottom. Then when we count the atomic number first. Nucleon number. Up here, we call it as nucleon number. Down here, we call it as proton number. Proton number. You all learn in chemistry already. Huh? So how do we know what is X? We just use the reaction here as equal sign 238 minus 234 X. Okay, maybe we do this. 238 equals to 234 plus X. So we say X equals to 4. Then 92 equals to 90 plus Y. So Y equals to 2. So we can get that the P would be 42. Only one radiation got 42 as the nucleon number and proton number. What is it? Alpha. Okay. So the equation like this.
Teacher,
Yes.
if the question provide in P, is it called atom P? So do we need to write it in atom P or we use helium?
We can say it's helium nucleus.
Okay, thank you, teacher.
Welcome. Teacher, after this can go back to the radiation 1, 2, 3. I want to copy. Can you mean this? Oh, okay. So alpha is a helium nucleus, helium for 2. Beta is an electron. We write it as electron, 0, -1. Gamma is a wave, so just write wave. Okay, and actually it's here already, so you can write here lah. Alpha is alpha He42. Should I write helium atom instead of P? Should I write helium atom instead? Normally they won't ask atom lah. It's not atom, it's a nucleus only. They would not ask atom, they will say, what is particles P? Particles means what? Particles means it could be atom, could be molecule, could be ion, means the charge positive or charge negative. So they won't ask, is it an atom? They will just say, what is the particles? So actually it's helium nucleus. It is a helium nucleus. Okay, jot down here for your summary. So your chemistry, I believe your chemistry teacher also always tell you, you cannot just say particles, you must mention is atom, molecule, or ion. So same as here, this is a nucleus only. No electron. No electron. For alpha, no electron. There's a positively charged. Alpha positively charged. Then beta is like that, negatively charged. Okay, so beta. Beta decay because they are excess neutron. So one neutron will transform into proton and neutron and electron. That's why carbon 14 become nitrogen 14. Okay, carbon. So just now I show you, right? 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 14. Carbon 14. They kick out one neutron, means become one proton. So carbon become nitrogen. So what is a beta particles? What is a beta particles? It is an electron. E0 -1. Now see, E0 -1. It is changed from one neutron become a proton and electron. So in exam, normally they would plus, let's say Q. Then they would say, what is particle Q? The same thing lah. What we do is we make two equations from nucleon number. Two equations of X and Y. One more equation for proton number. So now 14 equals to 14 plus X. So X becomes 0. 6 equals to 7 plus Y. So Y equals to -1. So what is Q? Q actually is 0, -1. What is it? Electron. means it is a beta. Okay. Okay, last, the gamma. What is a gamma? It's a wave. So just a wave. No. We just write gamma. So gamma, no particles. So 0, 0. So when you see why 60 as we can see the proton number. The nucleon number 60 equals to 60 plus 0. 27 equals to 27 plus 0. And nothing reduced. Means it is gamma. But what will be reduced here is only the mass. The mass before reaction. Before reaction will be higher than the mass after reaction. Your chemistry you learn right before, after. We say before is a material, after is a product. I was a pure science student before. I like chemistry. Okay, I still remember my chemistry teacher. Her name is Parizarita. All right, so now okay. So when I say alpha, immediately you know it's. When I say beta, immediately you know it's. When I say gamma, immediately it's. When I say what is radioactive decay, then Johnson, can you tell me? Johnson can tell me. Johnson. Johnson. Radioactive decay is blah blah blah, where or which blah 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 blah. Tại Lý N à, Lý N. Lý N 可以吗？可以试看吗？李 N。
A process
it's a process. 然后
which an unstable nucleus becomes stable.
unstable nucleus becomes stable. 记得要nucleus 或者是 nucleate. Okay, very good. Next, continue. So we already finished radioactive decay, alpha, beta, gamma. We are going to learn what is a half-life. Okay, so actually the radioactive decay is a series. See, this one, nitrogen. Just now, stable. Where? See, 1, 2, 3, 4, 5, 6. Carbon 14. 1, 2, 3, 4, 5, 6, 7, 8. Carbon 14, not stable. And then, so it will tends to emit out some radiation, then add 1 carbon. So it becomes Actually, it will become unstable again. Okay, it will become unstable again. So this one will continue. Transform one neutron to one proton and one electron. So the unstable process will become a series, means continuously. So for example, here, look at page 400. Okay, so for example, uranium-238 decays through a series of alpha and beta until it becomes lead-206. So uranium is 23892. Okay, ma? Okay, so now finally, when it really becomes stable, it will become a lead. Lead is plumbum 20682. Okay, so along this series, it will decay out a lot of alpha, beta, and gamma. So how much alpha is emitted out? Emitted out means kick out lah. Alright, so we can see we arrange the mass number in y-axis, x-axis as proton number. So 238 on y, 92 on x. Okay, then we arrange it as 4. Since we know alpha is helium-4, 2. Then, so here we becomes 1, 1. Does a neutron turns to proton when? Yeah, when neutrons turns to proton. Do you see helium first? So when the first series 23892 uranium become a helium, becomes something plus a helium, means these things would become helium-4, 2. Okay, then let's say this is something, some element here. So what is the atomic number here? It would be 234, and here would be 90. Means it decay 4-2, helium-4-2. So we say that's why how we see it's an alpha. When you see a Senghet line 4-2, so this is an alpha. Then how do we know? So 23490 become electron. So what will this be? So 234 become 234 because nothing changed here. So this one will become 91. Yeah, that's why you can see when beta is decay, when there is beta, so this is called alpha decay. When you see alpha decay, you will see it decrease to left hand side. When you see beta decay, you will see now the beta become to right hand side, go in front. Yeah, so the proton increase. And you can see that. When alpha decay, the arrow goes to the left hand side. When beta decay, the arrow will goes to the right hand side. So beta decay normally got 2 together lah, then only alpha again. So alpha got 1, 2, 3, 4, 5, 6, 7. So alpha decay got 8 ไหม? Yeah, 7, 8. Then Lisa, tell me how many beta decay here? Count from the graph. Lisa. 6. Let me count. 1, 2, 3, 4, 5, 6. Correct. X. So, conclusion, a summary here. This graph is a series of alpha and beta decay. Decay means the radiation is emitted out. Radiation is emitted out. So how to see from graph? When you see this means alpha. When you see this means beta. Okay? Then gamma. Gamma won't decrease proton number and nucleon number, so it doesn't matter. So from here, we cannot see gamma. We only can see alpha, beta. Okay, so now, when alpha, beta is emitted out, the radiation continues. Actually, this is the product. Okay, then this is the, this is the material, this is the product. The mass for the product always decrease. Okay, then let's see one video first.
Hi there, I wanted to do a quick demonstration.
Okay, this one is a machine that can detect radiation. Detect radiation. May I know what is a radiation, like a kaijun? What are radiations? Give me 3 examples. Kaijun? Kaijun? 可以吗？Kaijun？不可以，跟我讲一下，不可以。Not sure, no idea. Okay. 不是，我要 example. 我要 example of radiation. Aaron, I try.
Jake, sir, that was not me. That's somebody else.
Oh,
You're using my name.
oh, okay. Slap him. Yes, good. Yay! Thank you, Xinghe. Yeah. Detect radiation means detect alpha, beta, gamma. Okay. Okay, Darren slapped him in the school. Don't say I tell one. I recorded. I'm just kidding, okay? We are all good friends. We are all good students and teachers.
To show the 3 common types of ionizing radiation: alpha radiation, beta radiation, and gamma radiation. And to do that,
Okay, so when I say radiation, I'm saying alpha radiation, beta radiation, and gamma radiation.
I've got a simple Ludlum Model 3 survey meter with a Ludlum Model 44-9 pancake GM detector.
This is called GM2. GM2. Full name is Geiger Muller tube. A tube here. If you cannot remember Geiger Muller, you just remember GM2. Exam may ask, what do you use to detect radiation at GM2? Okay.
Attached. This type of detector has a thin olive oil. You can hear an inch or two.
Okay, so here this is a radioactive substance. Will give out alpha radiation. Then you can see the detector.
As I approach with this polonium-210 alpha source, alpha travels a very short distance, maybe a couple of centimeters.
The alpha only can travel short distance. When you put so near, only can detect
an inch or two in air. So you can see.
Okay, so and then the radiation actually is like a bullet. You can imagine there is invisible bullet keep going up. And if you can imagine if you put your hand here. Yeah, even though alpha cannot penetrate through your hand, but it will burn your skin. So alpha radiation, you will see the burning. That's what the Chernobyl's patient. You can watch the drama.
I've got to get really close, within an inch, before I can even detect that alpha radiation. If I hit the then I have to fall back down alpha. I've got a single sheet of paper that I'll slide in between the detector and the source, and you can see it takes a minute for that to fall back down to
Let's see if a paper can stop alpha radiation.
zero, but it's very easy to block out alpha radiation. Alpha is.
Okay, so now let's look at beta.
Dead layer of skin cells on our body. To demonstrate beta radiation, I've got a beta source here, and you can see already several inches away it's giving me a reading, so I'm going to range.
So you can see the long distance already can detect, and then it's also the radiation is continuously never stop one. So keep emits out the electron.
Up to the times 1 scale here and hit the reset button. Plexiglass.
Block. If paper still can penetrate.
My piece of paper and stick in here, and you can see that the paper doesn't do anything really. Plexiglass.
Normally we use plumber, a lead. And not lead. Aluminium. Aluminium can stop already. Now last is the gamma.
The button source here, and it's not a real strong source, so like source, these penetrating ability of this, and that doesn't do anything. It really.
Okay, even though the glass block and the paper cannot stop it. Only the lead. This is the lead. Plumber. The lead bulb, the lonta peluru, the bulb, only this one can stop.
In blocking out that gamma radiation. Take a couple sheets of that.
Must be at least how many cm? A few cm thick only can block it. Okay. What glass is that? I'm not so sure. They didn't mention much. Okay, so now we get penetrating power first. Penetrating power for alpha is low, beta is medium, gamma is high. So what can block it? What can stop it? Okay, what can stop it? We say alpha use a piece of paper can stop already. This one normally use aluminium block can stop already. But this one only lead can stop it. Means lead can stop the rest lah. Alright. Lead, the lonta peluru, or the chakra, lonta chakra, the short part, and the chakra, the disc. The material made up the lonta peluru and lonta chakra, that's lead. The lead can stop alpha. Or concrete. Means what? Means, let's say, if really got radiation explosion near to your house, you just close your close the window. If the heat doesn't kena your house, you close the windows and you stay in the concrete wall, because all of us, our house is made up by concrete wall, can stop the gamma, even beta and alpha. Okay. Yeah. So now is a continuous series. Means what? Means the nuclei, for example, X, to become Y, it will have, let's say uranium. Let's say uranium. Okay, just now we use this example. Uranium 23892 become plumber, means lead 20682 plus 8 alpha 6 beta, means this uranium will lose mass because it already emitted out alpha and beta and maybe gamma, but not recorded here. Okay, so lost mass. And then actually the time to lose mass for every object got a fixed time. Okay, so we say that what is half-life? Half-life means is the time taken for the time taken for time taken for the number of undecayed nuclei. Nuclei means plural of nucleus. To be reduced to half of its initial number. Or maybe we can write in this way. Half-life means is the time taken for the mass of undecayed nuclei to be reduced to half of its initial mass. So from this mass become half of the mass from original initial mass become half of the mass. This time taken, we call it as half-life. How to remember? Half-life. From here we can define already. First, what is life? What is used to measure life? Time taken. For example, my father lived up to how many years old? 71 years old. Okay, it means my father has 71 years old life. Means the time taken. Okay, so now half means half of initial. Maybe mass, maybe number. Okay. So now when I ask what is a half-life, you must be able to tell me it is the time taken for the mass of undecayed nuclei to be reduced to half of its initial number or initial mass. Time taken for the radioactive, or maybe you can say, if you don't want to say undecayed nuclei, you can say mass of radioactive substance to be reduced to half of its mass. Okay, 1 minute and I'll call you. It's a must to memorize it. Maybe. Okay, so may I know what is a half-life from Ginny 可以告诉我什么是 half-life 吗？
The time taken for the number of undecayed nuclei to reduce half of its original number.
Reduce.
Teacher, what is full life?
Huh? Sorry? Huh? Anyone say anything? To reduce to half of its initial number, or we can use for mass to reduce to half of its initial mass. Now, may I ask for another person, like Chipping 可以吗 ？Chipping 什么是 half-life？
Time taken for the number of undecayed nuclei to be reduced to half of its initial number.
Very good. Okay. Okay, so now, so we say that the decay period given, okay, this is page 200. Page 200. So, that's why the carbon dating, how we check the carbon dating, we check how much carbon it left, how much mass it left. So for example, after some time, it would reduce it after a time. Half-life, we will half-life. We will write as T half, the time taken to become half. To become half. Okay, let's say originally 100%. Then it will become 50%. then become one more half-life, it's a fixed number, it will become 25%, half of the initial. All right, so this is half-life. So now how do we check? This is an experiment, probability. You all learned in MS already the bell shape. If you have big number of sample, then you will have a bell shape things. So this one you read yourself first. I want to okay, there is a graph to shows half-life. So you treat this as 100% in the beginning, percent. Then after a half-life, let's say 3.5 seconds, then it will become 50. So this would be the half-life. And 50 become 25. Here would be another half-life. Okay, exam got this kind of questions. They give you a graph, ask you to determine the half-life from the graph. Means you need to draw the line here. You need to draw the line here, right? Right, so next week. So how do we solve the problem? There are two ways to solve the problem. One is draw the decay series. Another one, use the formula. Hello, teacher. Is it okay if I leave us? 5A is having PM. Okay, so maybe we stop here. Okay, so we stop here. Okay, thanks for everyone. Okay, bye.